All right, guys, this is the last set of notes for the week. Tomorrow I will be posting some problems for you to do and turn in by Sunday. So, to start, we talked about what component form is. So, component form basically separates a vector from its x component, or into its x component and into its y component. There's a picture of that right here. So, any vector has a starting and an ending point. And you can think of a vector as a movement over x and up y. So if you think of a vector as those two components, you can write any vector as those two components. And basically what you're doing when you do that is you're putting the vector, hold on here, you're putting the vector over here so that the point that's at the end of the vector is the same as the component form. All right, so how do we do that? Well, the easy way to think of it is like this. Well, if you're trying to find what the x dimension and the y dimension are of the vector, you subtract the x's for this part. So to go right, it's going to be x2 minus x1, and to go this vertical part, it's going to be y2 minus y1. So that's how you write any vector in component form. x2 minus x1, comma, y2 minus y1. So it actually is that simple. You just subtract the x's to find the x component, and you subtract the y's to find the y component. So the component form of this vector, if I want to know how do I write this just as the components, well, you subtract the x's. So 6 minus 3, comma, 3 minus 5. So the component form of this vector is going to be 3, comma, negative 2. So what that means is this vector goes right 3, down 2. So it looks like this. Now the points are somewhere else on the graph, but that's what this vector does. Okay? You can do the same thing with number 8. So on here, so the component form of RS is going to be negative 2 minus 5, comma 1 minus 10, which is going to be negative 7, comma negative 9. Meaning this vector goes left 7, down 9. All right? So once we're able to do that, then we can add this to what we did yesterday. So if I want to know the component form, magnitude, and direction angle, I know how to find the magnitude and direction angle with 2 points. I can just find the distance formula and then find this second tan of y over x. But once we put it in component form, it makes it a little bit easier. So let's start by putting this into component form. So the component form of mn is going to be 4 minus 2, and then 1 minus negative 9, which is 2, comma 10. So that's the component form of this vector. So we know this vector goes right 2, up 10. Okay? To find the magnitude, remember, the magnitude of mn is just the square root of a squared plus b squared. It's the square root of 2 squared plus 10 squared, which is square root of 104, which simplifies as, let me grab my handy dandy calculator over here. I believe it is 4 and 26, so it'll be 2 radical 26 for the magnitude. And then the direction angle is going to be second tan of 10 over 2, or second tan of 5, which we remember we always have to do what quadrant is this in. Well, 210 is in the first quadrant. So when we find our angle, we're just going to leave it. It is the reference angle. We don't have to move that anywhere else. So second tan of 5 is about 78.7 degrees. Okay, so there's the first one. So we're just kind of combining this with everything that we did yesterday. Let's look at number 10. First thing, component form. So component form of AB is going to be negative 4 minus 9, And if you want to try this on your own first and then check it, that's probably a good idea. -1 minus -3, so we get -13, comma 2, right? So what does this look like? Well, it goes left 13, up 2. So we're in the second quadrant here, just so you know. So to find the magnitude of AB, square root of 13 squared plus 2 squared, which is 169 plus 4 squared to 173. Don't believe that reduces. Let me just double check real quick. 173, let's try 9. No. Yeah, no, that one does not reduce at all. And then finally, the direction angle. Now, this one we're going to have to be more careful about. Remember, we make it positive. We make the numbers positive, and then we have to put it in the second quadrant. So second tan of 2 over 13. So let's see what that is. Second tan of 2 over 13, which is 8.7, right, degrees. But I need to put that in the second quadrant, so I need to do 180 minus 8.7 is 89.7. No, it is not. I typed something in wrong. 180 minus 8.7. Give me just a sec. Sorry, 171.3. So there's the direction angle. And that makes sense because it has to be going in the direction of that quadrant. All right. Number 11 is the same thing. Again, try it on your own first. See if you can get it. If you can't, just follow along. See if you can get it this time. So component form. Subtract the x's first. 7 minus 1, and then -4 minus 3. So we have 6, comma -7 as the component form. The magnitude of JK is the square root of 6 squared plus 7 squared. 36 plus 49 is 85. Which does that reduce? 85. Are there any perfect squares that go into that? I don't believe so. So that one we can just leave as square root of 85. And now again, what quadrant are we in here? Well, 6, -7 is in the fourth quadrant. So we make these positive, both the 6 and the 7, and then we have to put it in the fourth quadrant. So second tan of 7 over 6, let's see what that is. (49.4 degrees), but we want to subtract that from 360. And the reason we do that is because we want to put it in the fourth quadrant. So we take this, we subtract it from 360, and we get 310.6 degrees. All right, couple left here. Okay, this next one's the exact same thing. The nice thing is, component form is just the change in x and then the change in y. Well, how does this move? Well, it goes right 1, 2, 3, 4, 5, and then it goes down 3. So the component form of this vector is just 5, -3. If you wanted to write down the points and subtract them, that would be fine too. Magnitude of c, that's what this vector is called. Remember, the bold lowercase letters represent the whole vector. Is square root of 25 plus 9, square root of 34. And then the direction angle, same idea. What quadrant are we in? Well, I don't even need to draw it. We know we're in this quadrant. If I make it component form, it's going the same direction just from 0. So we're going to be in the fourth quadrant. You could also draw it yourself if you want, 5, -3. But we're in the fourth quadrant, so we're going to make these positive. 3 over 5, see what we get, and then put it in the fourth quadrant. So second tan, 3 over 5, 31.0 and subtract that from 360. So we get 329.0. All right, so that's what we're learning today. Now, the only other thing I want to talk about is vectors are equivalent. Now, to prove vectors equivalent before, I had to find the length of them, I had to find the slope, and show that they were the same, right? Well, if vectors have the same component form, then they're equivalent. Think about it like this. If I have, well, let's use this example up here. These vectors are equivalent. Even though they have different points, they both have the same x value and same y value. So the component forms are the same, which means that those vectors are exactly the same. They are equivalent to each other. So if I can show that the component forms are the same, that makes it show that they are equivalent. They are equivalent if they have the same component form. So all we have to do is find the component form of both of these. So AB and CD. So AB, component form, is -7 minus -3 minus -3, not 3, comma, -2 minus 6, which is -4, comma, -8. CD is -1 minus 3, and then -9 minus -1. So the component form of this is -4, -8. Notice, those are the same. So AB is equivalent to CD. They have the exact same component form. So we can do the same thing. If you want to try 14 on your own, go ahead. But AB and CD. Let's try AB first. I'm just going to do it without writing the first step here. 0 minus -9 is 9. -8 minus -2 is -6. CD is 4 minus -5, which is 9. And then 8 minus 2 is 6. Notice, are these the same? No. -6 is not the same as 6, so those are not equivalent. Okay, so that's it for today. Like I said, tomorrow morning I'll be throwing up a couple problems for you to do. Let me know if you have any questions. Thanks, bye.